I started.
You are ready to start? Ready?
Yes.
Hi, this is Deb Bhattacharya. I'm the chair for CT Society, formerly used to be called Consumer Electronics Society. Now it is called Consumer Technology Society. And this is the chapter for San Francisco Bay Area. And welcome to everyone here. And we have got exciting topic today, and we'll go over the introduction. Okay, so we will. This is the agenda of the meeting today. 12 to 12:10, we will talk about. I will talk about the introduction, and then 12:10 to 12:40, there will be presentation by Greg and Jason, and 12:40 to 1 o'clock is the question and answer, and it can go up to 1:30 if it is needed. Okay, during our meeting, please feel free to actually post picture and send your comments, concern by this kind of Twitter and link. So these 2020 officers are here. So I was the chair and Olga was the co-chair. And these are the persons who are actually officers for 2020. 2021, Olga will be leading with the chair, and I will be just assisting her as a co-chair. And we have Avid as the vice chair. Pat is both secretary and treasurer, and Joseph Wei is the webmaster, and Joseph Fong is the marketing chair. And we are waiting for other, officers to fill up the positions as they are interested. Okay, so we are seeking additional officers and volunteers for 2021 to help with speaker, workshop, social program, chair, and additional volunteers. So the next society meeting will be in January. Possibly we'll have the every time we have the CES review meeting. So we'll have probably towards the third week or fourth week of January, when the people come back from CES show. Okay, how many are IEEE members? Of course, we cannot see all of the people. Okay, how many are IEEE C members? Okay, so become a C member. Their membership is IEEE membership is $208, and you get 50% off your unemployed. And the CE Society is $30 per year, and student normally is $10 per year, but there is a special discount for student for $1 until the end of 2021. This is a special promotion. Okay, and if someone doesn't want to become a IEEE member but wants to become a C member or CT member, we'll call it rather, it is $75 plus $20 is total is $95. There are some member recruiting awards which any of you can actually go through and look at it in our website. So there are benefits of becoming a CE Society, City Society member, and there is a magazine that you get every month, and you can download the articles for free. And 2021 speaker topics and suggestions, you send it to me as well as you send it to Olga. So Olga's email probably you have, otherwise you contact me, I will provide the Olga's email. Job opportunities, if someone is looking for hiring, and please actually send your information to Olga and me, or if you know any other officers in the company, any officers in our group, IEEE City Society, please leave it to them. And job seekers, again, this is the same thing. if you are seeking a contract or full-time employment, please send email to Olga and me. Okay. So here is the speaker introduction. Our first speaker is Greg Kucheris. He is the product manager in NuCurrent. Greg did his BS in mechanical engineering from Cornell and MBA from University of Notre Dame. Greg is working as a product manager at NuCurrent and is responsible for product, platform development, and commercialization, partner development, relationship management, and business development. The second speaker will be Jason Luzinski, and he's a senior field application engineer for NuCurrent. And Jason did his BS degree in E from University of Illinois at Urbana-Champaign. And Jason is working as a senior FAE at NuCurrent and is working in the field of wireless power. Jason leads product definition, customer support, and IP strategy based on market requirements at NuCurrent. Our topic today is From Wearables to Cordless Kitchen, NFC delivers wireless power and data. Everybody knows about NFC, that it actually is tap to pay functionality and various tags and various kind of ways that you can actually communicate with NFC. So, and it is a secured communication. Now, NFC charging is emerging as a powerful solution for devices with power requirements up to 3 watt that can appear in products ranging from small wrist wearables to cordless kitchen appliances. In this 60-minute webinar, the NFC charging experts at NuCurrent will sit down with IEEE to share insights into this technology and its application, including how does NFC charging differ from QI-based charging, what products currently use NFC charging, and what products are high growth category for NFC charging. How do power and data work together in an NFC charging system? And now I will hand over the meeting to Greg.
Thank you very much, Dev. I appreciate that great introduction and walking us through what this webinar is going to look like. I'm happy to be here in front of IEEE and specifically the Consumer Technology Society. And thank you very much for having us and allowing us to talk about something that, quite frankly, gets us very excited, which is NFC charging and how it is expanding the wireless power platform and the wireless power roadmap. Jason, you go to the next slide. And applications for 2021 and beyond. As Dev mentioned, my name is Greg Kucheris, product manager here at NuCurrent. I've had about 20 years in the electronics industry. Jason Luzinski, beyond being just our senior field applications engineer, was also one of our lead designers. So he's got quite a breadth and depth of knowledge when it comes to wireless power. And I encourage you to ask your questions, no matter how technical today, because I'm sure he's up for the challenge. For those of you that are not familiar with NuCurrent, we are a wireless power technology company who has been innovating in the space for over 10 years. There are over 500 million products that are using our technology out on the market today. And we have mass production experience with Fortune 500 companies. It should read over 125 patents granted and pending. That keeps growing thanks to Jason and our engineering community. But we're also a contributor to the main industry standards of today, including the Wireless Power Consortium, Air Fuel Alliance, and NFC, of course, which is what we're going to talk quite a bit about today. And while we do work with several different chip suppliers, we are an NXP Gold partner, and we work with them quite closely when it comes to NFC power. The agenda today, we're going to talk a little bit of an overview about both NFC, how the charging adds into it, how is it different from Qi, what kind of advantages does the NFC charging bring to you from a wireless power standpoint. And then Jason's going to really dive into the geeky part of it, right? Talk about the architecture, talk about the performance capabilities, and some of the things that we're doing in NuCurrent that really drive the capabilities above and beyond where the standard is. We are going to pause somewhere in the middle for a Q&A, so we can just kind of ask some questions about the first half, and then we'll get into what are the current products and new products that are using NFC charging. How do you know if it's the right technology for your product, and how you can get started both with NFC or if you need to work with NuCurrent. And of course, we'll end with more questions at the end of the session. You'll see a little button there in the bottom that says Q&A. Feel free at any point in time when you have your questions to type them in there, and we will start to address them during the specific Q&A sessions. And if for some reason you drop or the whole session drops, just go ahead and jump right back in. We will all jump back in and we'll do our best to pick up from where we left off. So let's get going. So what is NFC, right? Near field communications. Dev already did a great job of introducing it. I'm going to go through it again, but it's a data protocol that allows two devices to communicate over a distance of 4 centimeters or less. So really, that real differentiator there is that only 4 centimeters of distance between the transmitter and the receiver. And what that benefit is, and the reason why people like to adopt NFC into their technology is, first of all, security. Not only is it an encrypted technology, but additionally, that 4 centimeters of separation distance means it's very hard for any nefarious individual to try and kind of lock in, get in the middle of a transaction, and try and actually hack into a device. So that's a real benefit. Number 2 is speed. And it's not pure data speed. You know, Bluetooth and Wi-Fi actually can pump more data through them, but it's really the connecting speed, the ability to immediately recognize, handshake, and communicate with the device that is unmatched, that makes it for such a great user experience. Again, that 4 centimeter or less means that there's very little crosstalk if you have multiple devices next to each other, unlike, as I mentioned, Bluetooth, Wi-Fi, even some of the newer protocols like LoRa or Zigbee that are designed to go feet or meters. You're not going to get any crosstalk between the devices because that field is only going out for 4 centimeters or less. In addition, that small distance means you don't need a ton of power to run the chips or to do the communication. You know, common applications already mentioned, tap to pair for IoT payment, whether it's with a credit card or with your cell phone, that's all being done over NFC, access control. Most hotels are moving away from those magnetic strips like credit cards and now going to NFC where you just tap to get into your hotel room. And of course, in today's COVID world, zero touch deliveries are becoming more and more important. A few terms I want to talk through very quickly. On the right, you'll see the picture there of the person with the POS terminal and the other person with their phone. That POS terminal in the wireless power speak, we would call that the transmitter. But in NFC, they use their own specific terms and they would call that the polar. On the other side is the mobile phone. In the wireless power speak, we'd call that our receiver. But on the NFC forum, they like to call that the listener. So keep that in mind as you do your own research. When it comes to NFC, you'll hear those terms, polar and listener. Really, you can think of them in terms of transmitter and receiver as well. So how does the charging add into this? And really, charging is an extension of that data portion of the standard. Where now, not only are we providing bits of data, we're doing power. Now, for those of you that are familiar with NFC, there was always actually some kind of power transfer capable, but it was less than 100 milliwatts. They called it power harvesting, and it wasn't really designed for continuous power transfer, charging devices, things of that nature. So what they've done now is they've actually formalized, and in May 2020, they ratified the first NFC charging wireless power specification. That now boosts up the transmitting power up to 1 watt per the specification. And as well, that data continues while the power is going on. And the data has dual purposes. Number one, you know, all the data you typically give to NFC, some kind of pass-through data, authentication, things of that nature continue to go on. But additionally, it also serves as in-band communication that helps to manage the wireless power field, ensuring safe and consistent wireless power transmission. Next, Jason. In terms of there's there are actually products out there in production that are currently using NFC Power, which is pretty exciting. And they've all been released somewhere within late 2019 and early 2020. The first of which was the Samsung Galaxy Fit, which is a fitness band transmitting about 170 milliwatts, or at least receiving 170 milliwatts. Second one was the Huawei Gentle Monster smart glasses. It's a collaboration between two companies in order to create a much better charging experience. Those are functioning around 150 milliwatts received and 106 kilobits per second of data that's being transmitted. And then Microsoft came out with their Slim Stylus to go along with their Surface line of laptops and tablets. And that's only about 50 milliwatts received. You don't need quite as much power for the pens, and 106 kilobits per second of data. But what's really exciting around the stylus, not just the Microsoft stylus, but the stylus world in general, is that just last month, a memorandum of understanding was developed between the Universal Stylus Initiative and the NFC Forum to make NFC charging the standard charging system for universal styluses. And the Universal Stylus Initiative, they're creating standards around active styluses so you can get a consistent experience from stylus to stylus and use them across device to device. So this is the first standards organization to officially adopt NFC charging as part of their standard. And I really expect that this is just the one of many we'll be seeing in the next year and in the years to come. Now, the reasons that they went for NFC charging versus other methods of charging or even other wireless power methods usually come down to the form factor of the device, the user experience that you're looking for, and the ability to transfer bidirectional data. You can see on the lower left-hand corner, the Huawei glasses. That's a really nice little pouch. All you have to do is drop those glasses right in the pouch to start the charging. But even more important is when you look at smart glasses, you have very little space to be putting your electronics and your antennas. You only got small area around the rims. You've got very thin frames and sides arms that go around where there's not a lot of place. And if you know anything about kind of a Qi wireless power, those large wire wound coils, there's really no place for them. NFC charging works at a higher frequency, allows for that much smaller form factor in antennas, and really plays very well into smaller and strangely shaped devices. Secondarily, user experience. You know, we played around with the Samsung Fit. It had two versions. A version that had the snap-on pogo pins, which you can see there on the left-hand side. And then on the right, you can see the magnetically attached wireless power. And it is really a night and day experience. Trying to get that thing snapped on, trying to wonder whether it's aligned right or snapped into place. And if you're a little bit older, trying to fumble around, trying to snap it off can be difficult. But it is just a far vastly better charging experience just to let that magnet pull it up and know that that power is being transmitted. And then the Microsoft Surface Pen with the bidirectional data, the way that they're using it is for system pairing. So you get that Surface Pen, you can pair it directly with your Surface laptop, your Surface tablet immediately and start to use it. So it really enhances the experience to be able to have that bidirectional and pairing capability. So this is a little about what's being done today. I'm going to hand it over to Jason. He's going to talk more about the details about how the technology works and how it really differs from Qi charging that you see out there in the market today. Jason?
Thanks, Greg. So to start things off, the Qi standard is based on transferring power. The initial applications were mobile devices, such as cell phones, with an intent to cut the cord and help bring a more seamless wireless experience to your phone. It operates in the 100 to 200 kilohertz range and allows up to 15 watts of received power. There is in-band data transfer, but it is only capable of about 2 kilobits per second and really is only used for charging specific information. The lower frequency of operation tends to lend itself to easier design with a more power electronics-based approach and can utilize fairly standard components. But it requires larger coils with higher inductances to ensure coupling and efficiency. NFC came from data and operates at 13.56 megahertz, with the original applications being things such as payment, entry, and identification. Now the NFC standard has added an extension to allow higher levels of power transfer that can address a lot of the issues found with trying to develop a Qi solution in these constrained form factors. The higher frequency allows higher data rates and allows designers to create systems that can be both loosely or tightly coupled, allowing for more spatial freedom. Current standard solutions allow up to 500 milliwatts of received power. This is based on the 1 watt NFC transmitted power spec and data transfer at about 106 kilobits per second. But NuCurrent is pushing these specs to address the more power and data hungry devices by being able to receive up to 3 watts of power and full NFC data capability up to 848 kilobits a second. We have brought the power levels up to address the form factor and power requirements of these small form factor devices, especially where Qi would not be able to provide a realistic solution. That being said, NFC is much more difficult and is more RF related, requiring simulation and design to address more sensitive magnetics, driver losses, as well as EMI concerns, which are harder to tackle at 13.56 megahertz. So how does an NFC charging system look like? NFC charging has a very similar block diagram to other inductive technologies with the addition of NFC controllers. As you can see, we have a DC to AC converter that allows us to generate an alternating signal on the coil, which generates a magnetic field, which the receiver picks up and converts it back to DC. We are adding here the NFC controls to allow for hitting the NFC timing requirements and the specific load modulation requirements that NFC has. This architecture allows you to easily integrate NFC charging if you already have NFC in your device, but you must consider the data and the power integrity that comes with higher power and data. I will cover some of the technical challenges in the next slide. Additionally, I would like to show 2 examples of reference designs NuCurrent has created. On the top left, we have a 1.5 watt dual temple charging application for smart glasses with an example of the receiver circuitry below. As you can see from the picture, the design is small enough to allow integration into a very constrained form factor, such as the temple of a pair of glasses. On the bottom left, we have our Stylance reference design that is in a metallic housing, and the pictures of the transmitter and receiver electronics should give you a good reference on the sizes possible with this technology. Additionally, the fact that the housing is metallic, we can actually use this harsh metallic environment to actually boost our NFC signal. So, one of the big things as you approach NFC charging, especially since NFC came from data and power does have its constraints with being able to transfer data efficiently, there are some major technical challenges that come with implementing an NFC charging solution, especially when combining data and power. The first things that come to mind are efficient magnetics, data and power transfer that meets NFC standards, and EMI. For this webinar, I will discuss probably the most difficult item, which is hitting the NFC timing requirements while transferring power. So to start things off, let's talk about high Q and low Q systems and how each affects power and data transfer. The top graph to the right shows the power response of a system operating 13.56 megahertz, with the y-axis showing power and the x-axis showing frequency. The sideband carriers represent the load modulation NFC uses for communication. Traditional wireless power systems rely on high Q to ensure that you have the lowest loss possible during power transfer. This results in a very large peak at the operating frequency. But as you can see by the pink line, the power attenuates very quickly as we move towards the sideband carriers, which degrades communication. NFC data systems rely on lower Q to ensure that you do not have to attenuate your sideband data carrier so that you can get reliable data between the transmitter and receiver and vice versa. The green line shows a lower Q system, and as you can see, that attenuation from the center to the sideband is much less, which ensures signal integrity. So what can you do? NuCurrent is implementing a technique from both wireless power and data systems to allow high Q antennas to increase the power with new tuning methodologies to increase data plus power capabilities in NFC. One method is to overcouple your NFC system, which allows you to maintain a high Q factor for power transfer, but prevent attenuation to allow for data. I recommend reviewing the paper that is referenced below for more information on this technique. The lower graph shows the bandwidth of 3 different systems with 3 different Q values in separation. On the x-axis, we have the TX-RX transmitter receiver separation, and on the y-axis, we have the bandwidth. Customers have different requirements, and sometimes you do not need the additional bandwidth to hit a design target. So let's talk about a situation where only 212 kilobits per second data is required. If you look at the bottom graph, the red line is a traditional NFC system with a low Q that allows for maximal spatial freedom to hit the user requirements while maximizing bandwidth. Think about this with tap to pay using a POS terminal where you don't have to put your phone directly next to the polar or transmitter to transfer your in-car credit card information. The black line is a traditional high Q antenna that is tuned in a traditional wireless power manner. In this example, we can see that in order to hit 212 kilobits a second, we must be above the green line to ensure we have proper bandwidth. This system would be able to deliver the necessary power, but would fail at providing the proper data throughput. The blue line shows how you can utilize high Q antennas with this tuning technique to optimize power transfer, but also hit the bandwidth requirement. Now, this works very well for highly coupled systems, but it's not the full solution. One of the benefits of higher frequency is not having to rely on coupling for efficient power transfer, which would make this very similar to Qi. NuCurrent has IP and simulation in addition to the method I just described, which improves performance for small form factors and large spatial freedom requirements. Finally, circling back to the NFC timing requirements, I wanted to show 2 time domain plots of a high Q and low Q system. On the left, we have a high Q system where we can see a long fall time, overshoot, which both would cause the system not to meet the NFC criteria. Both are a result of having an efficient resonating circuit, which increases the impact of reflections, overshoot, as well as increasing the amount of time it takes for the signal to decay during off or fall time. Traditionally, NFC systems would add a resistive load in the receiver path to help with these issues, but this is detrimental to power transfer efficiency. On the right, we have a low Q system, which does not have the same issues as the high Q system. As you can see, there is no to little overshoot, and we have a very fast decay time, which allows the system to hit the NFC timing specs. NuCurrent has spent 3+ years developing solutions to help our high Q system look and behave like the plot to the right to ensure that we can maximize power and data according to the NFC spec. Now, turning it back over to Greg.
Thank you, Jason. So what does this mean for product developers when it comes to using NFC technology? Well, number one, from a technical side, being able to transmit and receive up to 3 watts and up to 424 kilobits or 1 watt and 848 kilobits per second really allows you to replace interconnects that you might have used, physical connectors to make your electrons, whether it be power, data flow. You've got both your power and data now. And actually, NuCurrent has been able to develop solutions where we can have this NFC connection function as a UART pass-through, which means no extra software protocols are required. And really the big benefit is you can actually totally remove your debug port from your charging device. If you look at an Apple Watch today, even though it is using wireless power to charge it, it still has a small little connector on the other side of the device. And that's used for the developers to continue to debug during development, do firmware updates and things of that nature. But that also is still something that needs to be designed around, right? And so by using both the NFC power and data, you can completely eliminate the connector and have truly contactless and fully sealed devices. So from a product standpoint, it totally opens up your industrial design. Without having design around that 3-dimensional interconnect, you can really change up how you might put together your product. Additionally, really for sealing purposes, you can stick with standardized both molding, stamping, and sealing processes rather than getting into exotic things. I've had customers that we've spoken with who had to use 4 to 5 different customers and even 4 to 5 different suppliers or 4 to 5 processes just to get the sealing of their device that they require for everyday usage. By not having to go to that, by getting rid of the connector completely, you can stick with standard die cut adhesives, RTVs, and not have to worry about designing around that. And really the other benefit is removing that connector. Most people don't know is that if you're wearing a body worn device, that device is going to see some kind of unholy mix of sweat, suntan block, mosquito repellent, things of that nature, dirt, debris. All those things work against your connector, erode the plating, and at some point are going to degrade the performance, both of the power transfer and charging time, and really create a poor user experience and create defects and warranty claims. By removing that interconnect completely, you can lower the total cost of ownership, remove those or reduce your field returns, and provide for a better customer experience. So at this moment, I'd like to stop for a few questions. So Olga, I see you put a note here on the Zoom chat for your email address. Can I ask you first, did you receive any emails that we should be aware of before we go on to the other questions that have been submitted?
Checking at the moment, but guys, I unmuted everyone's microphone, so please go ahead and start asking questions if you want to ask it in open air. The mics are open. No, there was no question so far.
Okay, thank you, Olga.
But any questions?
Yeah, Greg, can you talk about a cost aspect, like what is the 0.5 ampere or 1 ampere? What is the typical cost compared to Qi system or something like that?
Yeah, compared to a Qi system, the one nice benefit I will say of Qi is that it is the first standard out there. It's been adopted by, millions of cell phones and charging devices. So it's creating some nice economies of scale. NFC has not quite achieved those economies of scale in terms of volumes, but it really depends on what kind of power and what kind of data transfer you're going to require. If you want to do what I would say is mostly around the bare minimum, what the NFC spec requires, which is around 1 watt transmitted and around 106 kilobits per second. Depending on volume, it's going to be maybe a slight premium over a Qi-based system, maybe a 20 to 25%. However, if you're looking to drive those data speeds up somewhere around 424, 848 kilobits per second, or if you're looking for special boosted power around 2 watts or 3 watts, like we've saying that we've been able to do with our extension, you're going to need some customized power amplifiers, boost regulators, things that are going to make this thing work appropriately, that all are going to add a little more cost into the system. In that case, you could find yourself with maybe 2 to 3x of what a Qi-based system might be.
Thanks, Greg.
I do see a question here about typical efficiency. What is the typical efficiency and range of an NFC charging device? Jason, do you want to handle that one?
Yeah, I see.
Go ahead.
Go ahead.
So specifically regarding efficiency, right now we are in the 60+% end-to-end efficiency, including the entire, essentially the entire system. So from DC power in to DC power out on the receiver, we see about 60+ at this time. From a coil-to-coil distance separation, it really depends on the size, but Qi systems or low frequency systems really rely on coupling to generate their efficiency. So you really see a quick drop off as you increase your coil separation related to 1/r². With NFC, the fact that we're not really relying on the coupling factor, but the high Q values of the antennas themselves and the high frequency of operation, we can have a much more uniform charging area. So you can see based off of that, we can really have a good charging experience, let's say 2, 3, 4, 5, 6 millimeters away from the device. Obviously, it's dependent on the coil sizes, and the general rule of thumb is that the optimal charge distance is 1/3 of the diameter of your receiver. but that can all be traded off depending on the requirements of the end system, whether efficiency is the main driving factor or user experience.
The next question is, what is the next evolution of NFC wireless charging?
Well,
Greg, you want to take that?
Yeah, I could take that. You know, it is the exciting thing about this standard is it's really in its infancy. As we mentioned, just in May was when the original standard was ratified at 1 watt transmitted. And as we've mentioned from a development standpoint, the NuCurrent's been able to show up to 3 watts of power transmitted. And I think that's a really exciting. It shows that, you know, typically you see a Qi-based system somewhere around 5 to 15 watts is fairly typical. So you're seeing a brand new element right in that 5 watt range for small devices. And I think it's really going to enable new devices, which we'll get into the second half. But I really believe, as I mentioned before, removing interconnects and potentially having these wireless connections that instead of using a connector like a lightning connector or something else, I think you're going to see quite a bit in that regard of being able to truly replace those with the wireless power and data between them. And I think that's going to be a major development. Another one that's not currently capable with a Qi-based system, strictly limited by the technology and by the approach, is being able to at some point do two receivers to a single transmitter. And high frequency systems lend themselves to being able to do that type of a charging system. And once you can do multiple receivers on a single transmitter, you open up a whole new different charging system. You can open up charging pads like what they're trying to do with the AirPower pad, where literally you can just drop several devices onto one pad and charge them all together. And I think that's a really exciting use case and really a game changer for a user experience that you don't get necessarily out of the technology today.
Thank you. Next one is the NFC is the only type of a system that your team has managed to charge in metallic environments?
So I can answer this question.
Thank you.
The nice thing about higher frequency designs. So to start things off, we have implemented wireless charging in metallic environments for both low frequency Qi solutions and for high frequency solutions at 13.56 megahertz for NFC and for 6.78 megahertz, which is Airfuel proprietary. The higher frequency designs tend to behave better within metallic environments because we can actually use the metal itself to help with eddy current generation and use those eddy currents to actually boost the signals. So we can structure the metals of products or use the environment that we see to be able to boost our signal and essentially get free efficiency out of it, increasing the coupling and providing additional benefits.
Thank you. The next question is from
Olga, I suggest that I don't want to use too much time here for the Q&A in the middle, so we make sure we have time to finish off. Can we move forward to the second half of the webinar and then get back?
Oh, yes, please go ahead. Can we answer the quick fast question? We have a product in development which will need wireless power to replenish a supercapacitor. How do we get started with your solution? That should be in February 2021 when we'll be at that stage.
Great question. We're going to talk about how to get involved, and you're going to see our contact information. Feel free to contact us after the webinar, and we'd be happy to talk to you further about your solution and how it might fit with our NFC Power solution.
Okay, so let's move on.
Well, perfect. So getting into the applications, right? What are people using now, and what are they going to use in the future when it comes to NFC charging? And I talked a little about removing the interconnect, but we spoke a little bit earlier about what's already out there. The NFC, the Galaxy Fit, so wrist wearables are of course adopting it. So anything else, fitness type wrist wearables are an obvious place that'll continue to grow. Smart glasses, because of the irregular shape and the small area for actual electronics, to embed antennas and such is another place we expect to see tremendous growth. And of course, we talked about the Universal Stylus Initiative already adopting the NFC standard. But beyond those three, we see, other areas that we expect to have significant growth. The lower left-hand corner, we talk about consumer and industrial wearables, and even beyond industrial wearables, we see medical wearables being a major point of growth. Anything that you're placing on your body, certainly in the industrial environment, tracking workers, ensuring worker safety, and measuring strain is becoming more and more prevalent, as well as medical devices and diagnostics that people take home and wear for an extended period of time to track the data. All these devices can be worn in harsh environments, whether it's out in a dust and dirty environment or at home where you have to shower and do other such things. They require not only powering, but also data transfer. And we see explosive growth within that area. Hearables is another place where things play extremely well, whether it's true wireless earbuds. Those tend to have of course, a lot of electronics packed into a small package, not a lot of flat surfaces or areas that it's easy for connectors and pogo pins. I've heard many stories and read many online about the pogo pin pads getting debris on them, making a difficult charging experience. Certainly earbuds is a great spot. Hearable devices like gaming and office headsets that are becoming more and more prevalent as people are working from home have their own unique shapes that the technology plays very well in. And of course, hearing aids are extremely small, very hard to put antennas and interconnects. And I can tell you from watching my father fumble around and trying to change the batteries in his hearing aid that he could do well with a very vastly improved user experience of being able to charge earbuds. So hearables we see as a major segment that has tremendous growth available. And the last one that I'll talk into more detail around is small kitchen appliances. And this is a little bit surprising because it comes from not just using the NFC charging, but using NFC and NFC charging as a complement to other higher power charging devices. And I'm going to talk a little bit about how those two fit together and why NFC is a good match for high power products. So when you talk about a higher power product, typical Qi right now, which functions from now, the standards from 5 to 15 millimeters, has in-band communication. It's able to transmit all that important information about foreign object detection and the power transfer and stability of the system, all within band. But as you pump that power up to hundreds and even thousands of watts, the signal just gets too noisy. There's just too much power, and it becomes totally impractical to use in-band communication, and you've got to use something at a different frequency. This is where NFC enters and allows you to provide that important foreign object detection, stability communication, power requirement communication to make sure you have safe and consistent wireless power transfer continuing to go by. You can see in the chart here on the right, on the top, we've modeled what we're calling a low frequency but high power system. And that would be your main power, whether it be for an industrial robot, whether it's for a drone, or perhaps even a high-powered computer. And layered on that is our NFC system, which not only provides the important communication, but also auxiliary power. So why do people want to use NFC in a complement in a high-power system? Number one, it's cost-effective and it's established. There are millions upon millions of products out there using NFC. It's a well-established standard, and because of the high usage, it's cost effective. Also because it's short range. You can imagine in an area like a distribution center that might have many robots next to each other that are being charged. There's no crosstalk that might come from a Bluetooth or a Zigbee type system. So it makes it very good for that short range, means none of that cross connection concerns. Additionally, it adds not only the data, but also the power. So whereas a Bluetooth system is only going to provide that data, when you get into situations like dead batteries or extreme sleep and low power modes, having that little burst of 1 watt or 2 watts transmitted to wake up the system, do basic electronic communication and handshaking before the main power turns on can be extremely valuable. And then thirdly, it's totally standards backed. There's a full NFC standards system behind it versus people who may be developing their own proprietary systems. And we're already seeing adoption. Both you've seen with the Universal Stylus Initiative. And then here we're going to talk about how the Key Cordless Kitchen is also adopting this standard. So I'm going to walk in a little bit about not just the general concept of high power with the NFC system, but the actual application that's being done with the Key Cordless Kitchen. So the Key Cordless Kitchen is a new standard that's being developed and soon to be released by the Wireless Power Consortium, who also have done the Qi standard as well. It is for cordless kitchen devices that function up to around 2,300 watts. And it's comprised of really 2 parts of the system. On the transmitter side, you're going to have some kind of what they call a kitchen hob or an induction cooktop or even an under counter hob. And what that transmitter does is it transmits full power to some kind of a small appliance that's placed on top of it. So that small appliance no longer needs to have a cord that goes to the 120 volt outlet and potentially be either a hazard or also is taking up extra counter space, because the real beauty of the system is that the system works on a similar type of technology as induction cooktops. So while you can use your induction cooktop to cook an egg or cook your dinner, you can also use that same spot to use an appliance, so that, you know, customers who have smaller kitchens or less counter space, a lot of apartments in Asia and Europe have this issue. These surfaces, instead of just being cooking surface, now become multifunctional, where they can do both kitchen prep and cooking all at the same time. The receiver is typically a small kitchen appliance like an air fryer, a blender, or a rice cooker. And in these particular cases, there's a low frequency system that's providing the main power, but the NFC provides kind of the auxiliary power and bidirectional data to ensure that you're getting safe and consistent wireless power transmission, as well as identification, and even it can provide information from the appliance to the cloud. I'm going to talk through kind of how this system works, and this is a simplified format of how the system works. But in the green here, I'm showing the NFC power and data, and the yellow is the low frequency main power. And the way the system works, and again, this is a simplified area, is there's a connected phase and then a power transfer phase. And on the left, you'll see the lady that's placing down the blender. This is called the connected phase. And in this phase, the NFC data is pinging for the device. And when it finds a device within the field, they start to communicate. They do the handshake. What are you? I'm a blender. Okay, am I in the right spot? No, you're not quite in an optimal location yet. All right, you're in the right location. How much power do you need? I need 1,000 watts. Okay, great. And once that they've decided that they're going to turn on the main power and that safe power is going to be provided, the NFC goes from a power and data mode to a data only mode. And on the right, you'll see that data only mode, so that the yellow is where the high power, main power is starting to come on. And the NFC is only being used for that essential in-band communication to manage the wireless power. I'll turn it over to Jason, and he can talk to you a little bit more about how that functions.
Thanks, Greg. Like you mentioned, we use the power transfer phase called slotted mode. Only NFC data is transmitted during the zero crossings of the low frequency and high power signal. At this time, NFC is handling the control loops of the low power, high frequency system, as well as transferring any product specific data between the appliance and the cooktop. Here is a zoomed in image of how the data and power is transferred during the slotted mode between the transmitter and receiver. Data can arrive at any time on either the receiver or the transmitter. The data is then packetized and queued up, waiting for the next zero crossing of the high power signal. Once we enter the zero crossing, we have a 1.5 millisecond window where the transmitter to the receiver data occupies the first third, and the receiver to the transmitter data occupies the last third of the window. We also use this window to provide all the control loop information for controlling the 20 to 50 kilohertz signals that are being shaped like a 50 to 60 hertz wave to power the appliances. But we can also pass information such as diagnostics, potentially additional IoT functionality such as data or being able to control to an app through this window as well. As Greg mentioned above, NFC has many benefits that led to its adoption within the key standard. To kind of summarize the points that Greg mentioned, during the startup and initialization phase of the appliance, both data and power enable the ability for a low power system such as a user interface to be powered and provide user feedback. Close proximity and the line of sight that prevents any crosstalk between appliances and allows for quick pairing. You can picture this especially if, for example, if this was implemented with a BLE or Wi-Fi solution. Latency becomes a really big issue once you have a lot of these radios within a room. The 2.4 and 5 gigahertz, let's say, channels are relatively laden with tons of devices nowadays. So this really helps us with pairing and prevention of crosstalk. And additionally to that, the no need for a battery or other power storage device to enable auxiliary system controls. The fact that we are able to transfer up to 3 watts of power means we can enable the communication and be able to power all the auxiliary circuitry within a product without needing to turn on the high power. From a safety point of view, the ability to utilize the high frequency NFC antenna for foreign object detection helps prevent dangerous heating, as well as authentication to allow the appliance and the hub or transmitter to know that there is an approved product placed in a safe manner before any high power transfer is started. From a standards point, both key and NFC are governed by widely accepted standards bodies that allow for infrastructure to be developed and deployed efficiently around the world. And finally, utilizing the bidirectional data channel, it allows OEMs to customize the products and provide differentiation to their end customers.
So as you can see, the NuCurrent slotted power mode as part of this NFC device really creates a real-time NFC communication during high power transfer. It provides for the efficient power management, great foreign object detection, automatic gain control, and authentication. And we do have development kits that are available for anyone who wants to both develop for the key standard or for other potential high power applications that could benefit from NFC and NFC power and data. So how do you know if NFC is the right solution for your product? And really, it can be quite simple to understand if you want to explore it. Number one, are you looking at a lower power requirement? As we mentioned, Qi tends to be 5 watts and above. Anything below 5 watts tends to be something that might be a good fit, specifically anything under 3 watts, because that's what we've been able to test out to. Do you require power and data, whether it's unidirectional or bidirectional data? Then NFC is probably a good fit. And then, of course, anything that's got unique form factors, a lot of curved, anything that needs to be body conforming or specific space constraints, the ability, and Jason showed you some of our demo designs for both the stylus and the glasses. You can see how small the electronics can be, how small the antennas are. NFC really is a great fit for anything of that nature. So if you want to get started using NFC charging, number one, join up with the NFC forum. There's a treasure trove of information about NFC, about how the new standard's being developed. It'll also, with your organization, allow you to provide some influence on where they're going. Number two, take a look at those products we talked about that are already out there in the field. The Galaxy Fit, the Huawei Gentle Monitor glasses, or the Microsoft Slim Stylus. Take a look at them, see how they operate, take them apart, get an idea of what it looks like. And thirdly, engage with wireless power experts like NuCurrent. We have multiple platforms that are developed around the NFC standard. Not only do we have what we call our Nueva general platform, where we can integrate NFC power into just about any device, but we also have application-specific designs already teed up and ready to be implemented, whether it's the AR smart glasses our Hearables platform or our wrist wearables, we can get you started at NFC very quickly. So I want to thank you very much for joining us today while we talk to you about NFC. You can see both mine and Jason's contact information is right there. We are going to get into some Q&A, but before we do get into the new questions and answers that are available, I wanted to have you make sure you saw our contact information. If you have any questions about NFC charging or wireless power in general, we're happy to field those questions and help you out.
Greg, Jason, thank you very much. I would like to open the questions to audience, and we have one already. So one is, what about security? Having a constant wireless data connection open 24/7 that can be activated and used by any device with compatible interface could be risky. Just think about Bluetooth hacks. Even high power energy transfer from malicious device can be very dangerous.
Yeah, that is correct. And, you know, one of the nice things about NFC is in terms of Bluetooth hacks, right? When you think about Bluetooth, Wi-Fi, Zigbee, they're radiating the signals quite a bit away from the actual device and product. One of the reasons why NFC has been selected for, you know, for example, payment is kind of that close proximity and line of sight situation. You know, obviously your passports are also using NFC for authentication and security. Obviously there are going to be potentials for man-in-the-middle attacks. So that's where encryption and authentication really comes in terms of the implementation of the product. But the fact that you require such close proximity helps relieve some of those issues. And obviously, there are a lot of other concerns that you have to look at when you're talking about security and risk. Regarding that, it's a 24/7 open wireless connection. The system itself is not transferring any information until you actually have a authenticated tag being placed in the field. So traditionally how these systems work is that your transmitter is sitting in an idle state. And then once you place the device close to it, the change in impedance on the transmitter coil allows the system to enable a analog and then digital ping to see whether a proper device is located out there. Yes, it is possible to sniff the packets, but with proper, you know, encryption, getting that data would be very, very difficult. And the fact that it requires close proximity, like I mentioned before, it makes it a little bit more secure than what Wi-Fi and Bluetooth are capable of.
Thank you. Another question we have is, what are the material considerations for embedding the charging coils?
So from an implementation standpoint, if you look at a traditional wireless power system, we have the ability to use standard printed circuits. Think of flexible circuits, FPCs, PCBs, FR4, polyimide, or wire mount coils. And then from a shielding standpoint, ferrite materials, similar to what you see in NFC systems, flexible ferrite sheets, sintered ferrites are what are used for designing the magnetics. From a circuitry standpoint, you know, it's a standard PCB with components that you can purchase from, you know, any of the big distributors or IC manufacturers.
Okay. Next one is,
sorry about that, Olga. One thing I'd add to that is not only just the construction of the antennas, but also a major consideration is the metallic and other materials that will be around the antennas. That's a major decision point and very important to be factored in to make sure you get the proper coupling.
Thank you. Next one is, do you have any customers, wearables or implants who have obtained an FDA approval as a medical device?
Great.
Do you have any customers, wearables or implants
Yes.
who have obtained FDA approval?
You know,
so go ahead, Greg.
It's an interesting question. The NuCurrent actually was founded based on antennas that were made for implantable antennas and implantable devices. So we've got some very important experience historically and current customers that are interested in doing that because of the in the body, any poor efficiency between the transmitter and the receiver is going to become heat. It's going to be very dangerous into the body. But I think Jason can talk a little more about what we've accomplished so far in that regard.
There are products available out on the market. I'm happy to field that question offline, but yes, there are products currently available in the market that use wireless charging as a solution for implantable devices. And on top of that, there are medical devices that are using wireless charging to help with sealing the devices, allowing the sterilization and other benefits that come with having a completely sealed device. So I can feel free to reach out to us. I can get your contact information after this, and I'll happy to fill you in a little bit more on the details.
Thank you. And guys, everyone, I will share and we will upload slides within a week. By the end of the week, everything will be available. Next one is, how can we get your dev kit?
For a dev kit, that's like it's from Chair Faraz. Feel free to send me a note, greg.kachuris@nucurrent.com. There's also on our website, if you go to www.nucurrent.com/SPDK, there's also contact form there. But the easiest way is just to shoot me a note and we can talk to you about how you might use the dev kit and whether it fits what you're trying to do.
Thank you. Next one, guys, I'm extending it for next 10 minutes so we can answer a little bit more questions. There's excellent questions. Can you please elaborate a little bit on passports with NFC?
So this is a fun little experiment. If you have an Android phone, you can download an NFC tag reader and take it and touch either, if you have a US passport, touch the back page of your passport, or if you have an EU passport, there tends to be a specific page, and it'll actually read you back your passport number. So embedded inside passports, you actually have an NFC tag plus coil that is encrypted with your biometric information and also a confirmation of your passport information. So when you walk through those personless, let's say kiosks, especially in Europe, where you place your passport in there, or even the global entry kiosks, what's happening is that the system is reading your front page where your picture's on it, and it's also confirming that data with what's stored on the NFC chip. So it's how they use for basically these quick passports, e-passports, allows for data information without needing to authenticate with a real person.
Thank you. Next one, what is the NFC forum tag type that use RX application?
We do type 2 and type 4 tags. We have the ability to support more, but it's dependent on application, right? So type 2 tags have specific requirements for the NFC layering and information that they store, and so do type 4. So it kind of depends on the application of data transfer you're requiring, but both are possible.
Thank you. Next question, is it theoretically possible to use some kind of signal amplifier to increase the range of communication?
Yes, so that's actually what we're doing with boosting the system power currently for both key and these wearable applications. The reason why we began down this path was that originally NFC was strictly related to data, which is pulsed power signals to deliver bits across. When you start talking about power transfer, now you have to really consider the continuous peak currents that you're going to be transferring through the system. Original NFC chips are not meant to handle those types of requirements, especially from the inverter stages, whether it's a full bridge, half bridge. They are not meant to sustain those higher levels of power. So what NuCurrent's done is actually we've implemented some RF amplifier topologies, Class D, Class E, to help increase the power capabilities of the NFC chips while maintaining the specific NFC timing requirements, like I stated earlier in the presentation.
Thank you. Next one, for US passports, starting what year do they have NFC capability?
I think it's been around for the past 8 years. So if you look at your passport, if you have the little symbol, it's a little square, a little rectangle with a circle around the inside. It's been implemented for quite a while now.
Thank you. Okay, any more questions? So let's wrap up the webinar. We're winding towards the end. Greg, Jason, do you want to say anything to close up the presentation?
I just want to thank you and Dev and Joseph, IEEE and the Consumer Technology Society for having us today. Again, we are very excited about this technology. So any chance we have to talk to you and inform the public about where technology is going from a wireless power standpoint is a joy for us. So thank you for having us. And again, if you have any questions about this NFC technology or any wireless power questions as they come along, feel free to reach out to either Jason or I, and we'll do our best to help you out.
Thank you, Greg and Jason. It was a pleasure to hear from you guys, the new way of charging by NFC, and it is something to think about. So,
yes, guys, thank you very much for today's talk. It was truly amazing and very awe-inspiring. I'm sure people will reach out to you about the developers kits, and to NFC technologies has a momentum, so let's use it. On that note, I'd like to thank everyone who attended today's webinar, and we will close this session. I wish you all happy holidays, happy new year, and we'll see you in January.
Thank you very much.
Thank you.
Thank you.
Bye.